Alright, so here's example 8 for probability. This is about quadratic functions and it's actually about designing it and testing it if a certain root exists or not. So let's work this out. So for part A, given a function f of x equal to 2x squared plus ux plus v, where u and x are arbitrary integers. Now for part 1 is we can set u equals 1 and v is taken randomly from the interval -20 to 20, both inclusive. So I will just write this in this notation right here. And then we need to find the probability that the equation f of x is equal to 0 has no real solutions. Alright, so when we're dealing with the existence of a solution to a quadratic, we must find the discriminant of that quadratic. In this case, it will be 1 squared, which is the value of u, minus 4 times 2, which is the coefficient of x squared, times v, which is the constant term. And since we want to show this has no real solutions, we must set this less than 0, or strictly less than 0. Here we have 1 minus 8v is less than 0, or in other words, v must be greater than 1/8. Now we can check back the solution back to our interval to see how many values of v satisfy this, and there are a total of 20 of them. So therefore our probability right here, since v is taken randomly, will be 20 over the number of integers in this interval, which will be 41. You can check that on your own. Alright, for part 2. This case, or this time, v is set equals to 3 and u is our variable right now. So u is taken from the interval -100 and 10. Find the probability that the equation f of x equals 0 has at least one real solution. So again, we can use the discriminant trick. So it will be u squared minus 4 times 2 times 3 in this case. And since we want to show that it has at least one real solution, it must be greater than or equal to 0, where equality happens when there is exactly one real solution. Solving this, you'll get u squared is greater than or equal to 24. And solving this in the integers, and by knowing that 24, the square of 24 is approximately 4 point something, and is very, very close to 5. And if you would round it to the nearest integer, it would be 5. So that's just a fact to use in this inequality. So the solutions are u is less than or equal to -5, or u is greater than or equal to 5. Now you can check these solutions and check how many satisfy in our interval. So for the first part, we can check there are 96 solutions, or 96 possible values, and for the second one we have 6, leaving us with a total of 102 of total values. Let me just write that neatly for you guys. Hence, our probability will be equal to 102 over 111, which is where 111 is the number of integers in this interval right here. Alright, for part B, given g of x is equal to -x squared plus ax plus b. This is another quadratic where a and b are obviously integers. If a pair of solution a and b, a comma b, is taken from the equation a times b is equal to 4, find the probability that the equation gx equals to 2 has no real solutions. And I just want to point out that the solution taken from a b is equal to 4 doesn't necessarily have to be always positive. It could be negative as well. Alright, so let's solve this. Now first we can write all integer solutions to the equation a times b is equal to 4. Now we can rewrite this solution in the form a comma b, and the solutions will be plus or minus 1 and plus or minus 4 and plus or minus 2 plus or minus 2 and plus or minus 4 and plus or minus 1, where these plus or minuses are, if we take a positive 1, must also take positive 4. If we take negative 1, we take negative 4. So the numbers we choose must have the same sign to give a positive product. Alright, so notice that there are a total of 6 solutions right here. 6 integer solutions, I should say. Now using our discriminant way to our equation, quadratic equation right here. However, notice that g of x, which is defined as negative x squared plus ax plus b, in the question it says it is equal to 2. So be careful when it's not equal to 0. So you must subtract both sides by 2, obviously. So this will give us negative x squared plus ax plus, we can write this in parentheses, b minus 2. To emphasize, this is the constant term in this equation. Now using our discriminant way, so our discriminant is equal to a squared minus 4 times negative 1. Notice that the coefficient of x squared is negative 1, so because we have a negative sign there. And then we have b minus 2. Now since it must have no real solutions, must set this less than 0. So therefore we have the inequality a squared minus 4b minus 8 is less than 0. Now given our pretty few solutions right here, we can substitute each value of a and b and see if it satisfies this inequality. And if you do that, the only solutions that satisfy this will be negative 1 and negative 4. Since a squared will give us 1, 4b will give us negative 16, and you can check this is negative. And we also have negative 2 and negative 2. So a squared will give us 4, 4b will give us 8, and again you can check that that is negative as well. Alright, so since we're being asked about probability, since we have two ways such that this event right here implies, or in other words, we have our equation g of x is equal to 2 has no real solutions. So the probability will be 2 over 6, where 6 is the number of possible solutions taken, as we found before. And we can simplify this to become 1/3. And this ends this example.